After I filmed that other portion, when I went to edit it, I realized that maybe I should do an explanation of just basically how to test diodes for anybody out there who's new to this whole thing and isn't really sure. You're just learning about it. So in your multimeter, you want diode test mode, and that's the schematic symbol for a diode there. It's sort of a little arrow with a line moving vertically and a continuation of that line that the arrow's on. You want to be in that mode, and you'll see it come up on your screen. When you touch your leads together, that would be a short. So basically with diodes, we'll use this one here as our first example. This is a 1N5408, fairly standard diode. You can look the spec sheets up for any of the diodes that you'll find online. Some can be a little bit difficult to find sometimes, but most of them are there. So with any diode, the quick check is the banded end. So whatever end is marked, this one has a silver stripe on one end. That's the negative end. That's where you want your negative probe to go. Positive probe goes to the non-banded end. And basically, if this diode is functioning properly, it will display a reading. It will actually be a voltage reading that will display on the screen there. So this would be 0.541. So this diode would be good in that direction. Anytime you test that way, then you test the other way. It shouldn't be letting anything pass the opposite way, and this one doesn't, so this would be a good diode. Now the acceptable range for diodes, you sort of have to look them up on the spec sheet because it's not always clear depending on the type, and these are just for standard diodes. Once you start getting into Zener diodes and certain Schottky diodes and things like that, this can change. But basically, if you have a diode that tests from 0.4 up to 0.7, 0.8, usually that's a safe range to know that they're good. There are certain types of diodes that actually do test up over 1 point something. So like I say, you have to check with the spec sheet. This is a 14007, probably one of the most common diodes used in circuits. This over here is the banded end, so that's where my black lead goes, my common, my negative. Red on the other side. 575. That's perfect for a 4007. So then we flip our leads around, we go the opposite way, put the red on the banded end, and oh well, not conducting at all in that direction, not letting anything pass. So that's perfect. That's a good diode as well. So that's just basically how you check diodes. Now, to check them for resistance, well, we might as well use this one again. I had flipped it around there, so we'll put the banded end back where it should be. So if we touch that to the proper end, or black to the banded end, we get 2.3 meg. If we flip our leads around the other way, should be OL, right? And that's what we get. So that would be a good diode. Let's do the same with this 5408. So banded end first. This one we get almost 1.5 meg. Flip them around. Nothing. So once again, good diode. So you can check your spec sheets, but that can be a quick initial thing that you can do to go through and check and see if they're bad. Sometimes you can do this in circuit, sometimes you can't. It depends what else is in there. So check it in the circuit board. If you're getting funky readings then, or it measures bad, pull it out just to be sure, because maybe you'll have to replace it anyway. Okay, so just one more quick thing here. We might as well deal with transistors, because transistors are these type of semiconductors. They're essentially diodes in a different configuration. You can look up a bunch of information on how to check these, but this particular one that I have here, this is a 7815 transistor. Transistors, usually they're PNP or NPN. I'll let you go look it up and figure that all out. There's other videos and information out there on that whole thing. Essentially what you want to do when you're testing these though is to Take one lead, put it in the center, and you're going to go to the right side with your black lead. So we get a reading of 0.870 on this one, and then you just take your black lead over to the other side. We get 585 on the other side. Okay, that's all well and good, you know, that's within our diode ranges that we'd expect. So then we reverse the leads, and this time our black goes in the center. And red goes to the outside, and we get 2.3. So we'll swap that around to the other side. Another 2.3. Okay, so is that at odds with what we just learned about diodes? Well, sort of. So the reason why I want to pick this one is because it does give you that 2.3 reading. A lot of times in circuits, even with regular diodes, if you're testing them in circuit, you should get the proper reading one way, unless there's two diodes in parallel, or, you know, some resistor or something else going on in the circuit. If it reads properly the way, you know, with black to the banded end, but then you flip it around and you get a reading 2 point whatever, oftentimes you can sort of make the guess that that diode is good. It's something that happens in circuit quite a bit, depending on, you know, your multimeter and the way that things are arranged in the circuit. So it would be a pretty safe bet that that diode's good. Now, this is the case sometimes with transistors. Now, certain transistors, you get this because there's other things going on inside the transistor. It's not just two diodes, you know, in that NPN or PNP configuration. But, you know, if you test it this way and you get that, that's pretty much the same as an OL reading, as it being open. I wouldn't worry about that too much. That would probably more than likely be within spec. And since these readings sort of agree with what we'd want the transistor to measure, you know, this one would likely be okay. Let's see if I got something else in here that's different. This one's a 3N80C, so let's see what we get with this one. So we'll do red in the center, and then to the right. We have nothing, and the other side we have nothing. So then we flip our leads around, do the same thing. So we should be expecting some sort of reading this time, right? We get 547. So is this transistor good or bad, based on what we just encountered there? The simple answer for, you know, any of the beginners out there is that it's not always as simple as just diode test mode. Certain types of transistors, you know, they have to have a voltage applied to them before a switch will come on and they'll start conducting on one side. And, you know, the only way you'd know that is by looking at the spec sheet, and you have to know what some of those parameters mean. So if you're getting into anything like this, it's probably more advanced than the beginner's going to be dealing with anyway. So, yeah, don't be too alarmed. But, you know, just off the cuff from what we learned, I'd probably say that this transistor is bad, that it's not functioning properly. However, best to check with the spec sheet and, you know, make sure that's actually the issue before you just sort of say, oh, this is it, and replace it, and then you know, power your unit up and it's still not working, or it's blowing fuses or whatever. So I hope that helped you. Just a brief little primer video on diodes and transistors and how sometimes they can trick you. That was sort of the take-home message from this one. But as a general rule, that's how diodes operate.